I feel like usually when we talk about a major medical breakthrough, there's this expectation of pristine laboratories.
Right, like a movie scene.
Exactly. The scientist is in a spotless white coat, looking through a microscope, and then suddenly they gasp and say, "Eureka! I've found the cure."
Yeah, it's clean, it's sterile, and it's an environment that's just completely separated from the messy reality of nature.
But then you step into the actual history of immunology, and suddenly that spotless lab just totally disappears.
Mm.
I mean, we were looking at a landscape full of barnyards, cowpox, and baby birds pushing each other out of nests.
It is pretty much the absolute definition of a messy, deeply interconnected natural world.
Welcome to today's deep dive. Today, we are tearing up the sanitized textbook summary of the world's first vaccine. We are exploring the life of Edward Jenner.
Right, the 18th century English physician widely known as the father of immunology.
But we're looking past the basic dates and facts today. Our mission is to unpack how a childhood medical trauma, an apprenticeship with a radical surgeon, and a bizarre obsession with baby cuckoo birds all perfectly aligned.
And how all of those things helped one man save more lives than anyone else in human history.
Because the real story of the vaccine isn't just a story of human medicine, is it?
No, not at all. It is a masterclass in cross-species problem solving.
Okay, let's unpack this. Because to really understand the sheer magnitude of what Jenner achieved, we have to understand the terrifying reality of the world he was born into.
Yeah, it is genuinely hard for us to overstate just how devastating smallpox was. The philosopher Voltaire actually documented the statistics of the era, and they are chilling.
What were the numbers like?
Roughly 60% of the population caught smallpox, and of the total population, 20% died from it.
Wow. 1 in 5 people just gone.
Gone. And the numbers were even higher in towns and cities, where people were packed closer together.
Right, because it was highly contagious.
Exactly. We are talking about an airborne virus that caused severe fever, vomiting, and skin eruptions that left survivors horribly scarred, or in many cases, completely blind. It was a constant looming shadow over every family.
And the really wild part is that the preventative measure they had at the time, the best medical intervention available, sounds like absolute madness today.
It really does.
There's a process called variolation. I mean, whoever came up with this was operating on pure desperation.
It was definitely born of desperation, but it had a strange logic to it. Variolation had actually been practiced in Asian and African medicine for a very long time.
Oh, really?
Yeah. Well before Lady Mary Wortley Montagu brought the idea to Britain in 1721 after seeing it in Constantinople, the idea was to take actual live smallpox material, so pus or scabs, from someone who had a mild case of the disease and scratch it directly into the skin of a healthy person.
So it's like setting a controlled burn in a forest. You're starting a fire on purpose to burn off the dry brush, hoping the wind doesn't change and burn down the whole town.
That is a brilliant way to put it. You are intentionally causing an infection, praying it stays localized so the person develops lifelong immunity.
And did it work?
Well, there were successes. A man named Johnny Notions in the Shetland Islands famously devised his own localized variolation method, and he supposedly never lost a single patient.
That's incredible.
It is, but he was the exception. On a broader scale, the wind changed constantly.
Because you're giving someone actual smallpox, you have no idea if their body can handle it.
Precisely. They could develop a severe fatal case right then and there. And worse, the person who was variolated became a walking biohazard.
Because they were fully contagious.
Right. By trying to protect one person, you could accidentally start a brand new deadly epidemic right in the middle of a crowded city.
I am just trying to imagine the sheer terror of being a parent back then. You have to actively choose to cut your healthy child's arm open and rub lethal disease into it.
When you have a disease killing 20% of the population, a horrific gamble suddenly looks like the lesser of two terrors. And this wasn't just abstract theory for Edward Jenner.
Right, he didn't just study variolation, he survived it.
Exactly.
When he was a young boy growing up in Gloucestershire, he was subjected to this exact procedure. And it wasn't just a quick scratch either.
No, it was an ordeal. The medical protocol for variolation at the time involved weeks of preparation. They were bleeding, purging, starving the patient beforehand to, quote, balance the humors.
That sounds absolutely barbaric.
It took a massive physical toll. Surviving this crude procedure actually permanently damaged his general health for the rest of his life. It was a deeply traumatic medical event.
But it didn't push him away from medicine?
No, it pulled him directly into it. He knew intimately how flawed and dangerous the current system was, so by the age of 13, he apprenticed himself to a surgeon.
So if you survive this horrific, archaic medical trauma, and you realize the establishment doesn't really know what they're doing, you naturally start questioning everything,
Right, you stop taking medical tradition as gospel.
which perfectly primes him for the mentor who changes his life. He eventually lands at St. George's Hospital in London, apprenticing under a highly influential and incredibly unorthodox surgeon named John Hunter.
And Hunter gives him a piece of advice that is basically the ultimate Enlightenment era battle cry. He tells young Jenner, "Don't think, try."
Don't think, try. I love that.
It sounds simple, but it was revolutionary. Medical practice at the time was heavily reliant on ancient texts and philosophical theory.
Lots of debates, not a lot of experiments.
Exactly. Hunter was telling Jenner to stop philosophizing in an armchair, get your hands dirty, observe nature directly, test your assumptions.
And Hunter didn't want Jenner just looking at human cadavers either.
Yeah.
He pushed him into natural history, zoology, the study of animals.
Which is where Jenner's story gets so delightfully bizarre.
Seriously, because in 1788, Jenner is elected to the prestigious Royal Society. But it has absolutely nothing to do with human medicine. It's for his research on cuckoo birds.
It is a stunning display of what happens when you apply "don't think, try" to the natural world. At the time, everyone knew cuckoos practiced rude parasitism.
Right, where the adult cuckoo lays its egg in the nest of another bird species, like a hedge sparrow, and just abandons it.
The ultimate deadbeat parents.
Yeah, exactly.
But there was a biological mystery. Shortly after the cuckoo egg hatched, the other eggs and chicks in the nest, the host's actual babies, would inevitably be found dead on the ground below.
So what did people think was happening?
Yeah, the established scientific consensus was that the adult cuckoo must secretly return to the nest to commit this murder to ensure its offspring got all the food.
Because obviously a tiny, newly hatched bird couldn't do it. But Jenner actually climbs up, stakes out the nests, and watches.
And what he discovers is straight out of a horror movie.
Right. It isn't the adult bird doing the killing. It's the newly hatched, blind, naked, featherless baby cuckoo.
Jenner proved it through painstaking observation and dissection. He discovered something incredible about the baby cuckoo's anatomy. It has a temporary depression, like a physical cavity in its back.
Wait, like a dent.
Yeah, a dent perfectly adapted to cup the shape of the host's eggs or the other chicks.
That is wild.
The blind baby bird maneuvers itself under its nestmates, uses this cavity to hold them steady, and literally heaves them over the edge of the nest.
It's an evolutionary adaptation purely for murder. And the wildest detail is that Jenner noticed this anatomical feature completely disappears after 12 days.
Right. Once the nest is clear, the bird's back fills in and becomes normal. It is a temporary biological weapon.
That is just mind-blowing.
It was such a radical discovery that the scientific establishment flat out refused to believe him. The idea that nature could be so ruthlessly calculating and that a blind chick could perform such a complex mechanical feat was unthinkable.
So how did he prove it to them?
Well, it wasn't until much later. A Scottish artist named Jemima Blackburn actually witnessed and illustrated a blind nestling pushing out a host's egg, and that vindicated Jenner completely. Her illustration was so irrefutable that it even prompted Charles Darwin to revise a later edition of On Origin of Species.
Okay, this is a phenomenal piece of natural history. But I have to ask the obvious question. What on earth does baby bird murder have to do with curing smallpox? How do we get from a nest in a tree to a global vaccine?
It's all about the lens it gives him. Jenner's cuckoo research gave him a profound structural understanding of animal biology. He wasn't just a human doctor anymore. He was a zoologist.
Oh, I see.
He understood how deeply interconnected different species are, how biology adapts to solve problems. This cross-species fluency, this ability to look at humans and animals as part of the exact same biological tapestry, was exactly what he needed.
Because the solution to smallpox wasn't in a London hospital. It was hiding right there in an English barnyard.
Exactly. So when he goes back to the countryside to set up his medical practice in Berkeley, he's no longer looking at the farm animals as just livestock.
Right, he's observing them with that same meticulous scientific eye he used on the cuckoos.
Precisely. And to understand what happens next, we actually need to clear up a major historical myth. You've probably heard the story of the beautiful milkmaids.
Yes, the famous legend that Jenner noticed the local milkmaids always had flawless, unblemished complexions because they never caught smallpox. And that singular aha moment led to the vaccine.
It's a very romantic story, but it's heavily exaggerated, if not entirely invented, by his later biographer, John Barron.
Wait, really? So that didn't happen?
The truth is much more grounded in a shared, gritty agricultural reality. Jenner wasn't the first person to notice that getting cowpox, which was a mild, localized disease transferred from the udders of cattle to the hands of farm workers, seemed to protect you from smallpox.
Right, the farmers already knew this. Back in 1768, a physician named Dr. John Fuster realized prior infection with cowpox granted immunity. And in 1774, a Dorset farmer named Benjamin Jesty went so far as to take cowpox pus and purposely scratch it into the arms of his wife and 2 children during a smallpox outbreak.
And it worked. They survived.
So the raw observation wasn't Jenner's unique stroke of genius at all.
No, his true contribution, the thing that fundamentally changed medical history, was taking that rural folklore and applying rigorous, verifiable science to it.
He used the don't think, try method.
Exactly. He didn't just notice the immunity. He recognized the biological mechanism at play, and he set out to scientifically prove the cross-species transfer through a terrifyingly bold experiment.
And that leads us to May 14, 1796. Jenner finds a local milkmaid named Sarah Nelms. She has fresh cowpox blisters on her hands, which she caught from a cow named Blossom.
And as a wonderful historical aside, the hide of Blossom the cow was preserved and actually still hangs on the wall of the St. George's Medical School Library in London today.
That is amazing. So Jenner takes some of the pus from Sarah's cowpox blisters. He then recruits an 8-year-old boy named James Phipps, who is the son of his gardener.
Right.
Jenner makes 2 small cuts on the boy's arm and rubs the cowpox pus into them.
James develops a mild fever, feels a bit uneasy for a few days, gets a small localized lesion but recovers quickly. He doesn't get a full-blown dangerous infection.
Which makes sense. But why? What is actually happening inside the boy's body?
Yeah.
I mean, we know cowpox and smallpox are related, but how does one defeat the other?
Well, it comes down to how viruses interact with our cells. Think of a virus like a lock and key.
Okay.
The cowpox virus has evolved over millennia to perfectly fit the locks on cow cells. When it enters a human body, its key is clunky. It doesn't fit human cells very well. It can cause a mild infection, but it struggles to replicate quickly.
So it's basically stumbling around, giving the human immune system plenty of time to recognize the invader and build specific defenses against it.
Precisely.
It's like handing the immune system a wanted poster of a criminal. The body studies the face, learns exactly how to fight it, and neutralizes the threat without being in real danger.
That is a fantastic analogy. And because the smallpox virus and the cowpox virus belong to the same family, they look incredibly similar to the human immune system.
So once the body knows how to defeat cowpox, it automatically knows how to defeat smallpox.
Exactly. The wanted poster works for both criminals.
But knowing it in theory and proving it in reality are 2 different things. Which brings us to the second step of Jenner's experiment. The step that, quite frankly, is terrifying to think about.
Oh, absolutely.
On July 1st, about 6 weeks later, Jenner intentionally injects 8-year-old James Phipps with actual lethal smallpox.
He performs standard variolation, the exact same procedure that traumatized him as a child. Normally, this would result in a smallpox infection.
But at this time,
Nothing happens. James Phipps doesn't get sick at all. The cowpox infection had given him complete, robust immunity to the deadliest disease on Earth. Safely.
Jenner achieves the goal of variolation without the horrifying risks, and he makes sure everyone knows exactly where this miracle came from. He coins the terms vaccine and vaccination from the Latin phrase variole vaccine,
which literally translates to pustules of the cow. He permanently cemented the cow's role in this triumph. He wasn't hiding the messy cross-species nature of his cure. He was highlighting it.
But wait, you've just cured the world's worst disease using cow pus. You've proved it works on 1 kid. You can't just publish a paper on a sample size of 1 and change global medicine.
No, you really can't.
How do you actually get the medical establishment to believe you? Because injecting animal diseases into human beings must have sounded completely deranged to a high society London doctor.
Oh, it was highly controversial. The Royal Society initially rejected his paper. They told him the idea was too revolutionary, too bizarre, and he needed an undeniable burden of proof. He couldn't just have one success story.
So he goes back and repeats the experiment. He rigorously tests his hypothesis on 23 additional subjects over the next couple of years.
And this is where you see the absolute, unwavering conviction of the man. To prove to the world that this wasn't just safe but essential, one of those test subjects was his own 11-month-old infant son, Robert.
Wow. You have to sit with the sheer medical weight of that decision.
You really do. He was so certain of the biology, so confident in his meticulous observations of how species interact, that he staked his own child's life on it. It wasn't recklessness, it was absolute scientific certainty.
And it worked. The evidence became a mountain that the medical establishment simply couldn't ignore. Eventually, the British government not only accepts vaccination, but by 1840, they completely ban the old, dangerous method of variolation.
They even start providing cowpox vaccinations entirely free of charge.
That's huge.
But the truly staggering part of this story is how fast it leaves Britain. The global spread of the vaccine is one of the most incredible logistical achievements of the 19th century.
That's exactly what I'm wondering about.
Right.
How do you distribute a vaccine globally in the early 1800s? You don't have refrigeration. You can't just put active cow pulse in a glass vial and sail it across the Atlantic for 3 months. It would spoil instantly.
It was a massive logistical nightmare. The solution they found was both ingenious and deeply indicative of the era.
What did they do?
Between 1803 and 1806, the Spanish launched a massive philanthropic mission called the Balmis Expedition, led by Dr. Francisco Javier de Balmis. Their goal was to transport the live smallpox vaccine across the ocean to the Americas, the Philippines, Macau, and China.
But how do they keep it alive on a woody ship for months?
They used a human chain.
A human chain.
Yeah. They brought 22 orphan boys on the ship. They vaccinated 2 of the boys before they set sail. About 10 days later, when the cowpox pustules on those boys were at their peak, the doctors extracted the fluid and used it to vaccinate the next 2 boys.
Oh, wow.
They kept this sequential living chain going all the way across the Atlantic Ocean. The human body became the refrigerator.
That is just, wow. It's a completely wild, messy, intensely human solution to a biological problem.
It really is. Even Jenner was stunned by it. He said he couldn't imagine an example of philanthropy so noble and extensive.
The sheer power of what Jenner discovered transcended everything. It even crossed enemy lines during active wartime.
Right. Britain was at war with France, and Napoleon Bonaparte was the sworn enemy of the English. But Napoleon recognized that smallpox was a far greater threat than any army. He had his entire French military vaccinated using Jenner's method.
Didn't Jenner actually write a letter to Napoleon asking for a favor during the war?
He did, yes. Jenner requested the release of 2 English prisoners of war who were being held by the French. And Napoleon, the great adversary of Britain, personally agreed.
Really?
Yes, he released the prisoners, famously stating that he could not refuse anything to one of the greatest benefactors of mankind. The vaccine literally stopped wartime politics in its tracks.
Jenner goes from a rural country doctor, a guy dissecting cuckoo birds in the woods, to an absolute international hero.
An absolute legend.
The UK Parliament recognizes the magnitude of his contribution and grants him massive sums of money, first £10,000, then another £20,000. The goal was to let him quit his regular medical practice and dedicate his life entirely to the distribution and study of vaccines.
He continued his work tirelessly, while also quietly returning to his beloved natural history studies, right up until he died of a stroke in 1823.
But the real conclusion of Jenner's story happens over a century and a half later, doesn't it?
Exactly. The ripple effect of his don't think, try mentality culminated in 1980 when the World Health Organization officially declared that smallpox, the disease that had terrorized humanity for millennia, was completely eradicated from the face of the earth.
It's easy to look at this as just a fascinating piece of ancient history. But the reality is, every time you get a flu shot or any modern vaccine, you are participating in the exact same cross-species biological hack that Jenner proved with Blossom the cow.
That's right. Many present-day vaccinations still utilize animal components, from cows, chicken eggs, or rabbits, to safely train our immune systems. We are still relying on that fluid boundary between species.
Jenner's life is a testament to the fact that knowledge is most valuable when it is rigorously applied. He didn't just observe the world, he intervened to fix it.
And despite the international fame, he remained incredibly grounded. A few days before his death, he remarked to a friend that he wasn't surprised men weren't grateful to him, but he wondered why they weren't grateful to God for making him the instrument of conveying such good to his fellow creatures.
It's a staggering legacy. We've gone from a traumatized boy surviving an archaic, dangerous procedure
to a zoologist discovering the murderous habits of baby cuckoos,
to a man who convinced the entire world to inject themselves with cowpox to defeat a global killer. The path wasn't a straight line in a sterile lab. It was a messy, deeply interconnected journey through the natural world.
He showed us that the answers to our greatest threats might just be hiding in the animals we walk past every day.
Exactly. But before we wrap up today, I want to leave you with one final, lingering detail from the history books to mull over.
Oh, this is a good one.
We just celebrated the fact that smallpox was completely eradicated in 1980. The disease is gone from nature. It no longer circulates in human populations.
Right.
However, samples of the actual smallpox virus, live, lethal, civilization-ending material, still remain locked away. They're heavily guarded in two highly secure laboratories, one at the CDC in Atlanta, USA, and the other at the Victor Institute in Russia.
Still there today.
So I want you to ponder this. If Jenner helped us entirely wipe this horrific disease off the face of the earth, what does it mean that humanity has deliberately chosen to keep the ultimate killer alive in a freezer? Thank you for joining us on this journey. Keep questioning, keep exploring, and we'll see you on the next Deep Dive.